Hello students, welcome to the video class for the subject Power Electronics and PLC. So this video is for 5th semester Electrical and Electronics Diploma Engineering students. So today we will cover about the different parts of PLC by drawing the block diagram and purpose of each part of PLC and applications of PLC. So the different parts of PLC is different parts of PLC. It means what is inside a PLC. So the PLC mainly consists of a CPU, a memory, a memory area, then appropriate circuit to receive input and output data. So we can actually consider the PLC to be a box full of hundreds or thousands of separate relays, counters, timers and data storage locations. Okay, so this is your block diagram. See, this is input circuit, CPU, memory, output circuit. It can be expanded as input relay, counter, output relay, internal utility relay, timer, data storage. So these are all inside a PLC box. So next we will see the purpose of each part of the PLC. So first one is the input relay, or you can say it as a contacts. So these are connected to the outside world. They physically exist and receive signals from switches, sensors, etc. Typically they are not relays but rather they are transistors. And the next one is the internal utility relay. This is also one contact. These do not receive signals from the outside world, nor do they physically exist. They are simulated relays and are what enables a PLC to eliminate external relays. So there are also some special relays that are dedicated to performing only one task. So some are always on while some are always off. So some are on only once during the power on and are typically used for initializing data that was stored. Then the next is the counter. See, here is counter. So the next one is counter. So these again do not physically exist. So they are simulated counters and they can be programmed to count pulses. Typically these counters can count up, down or both up, down. And the next one is the timer. So the timer, this is your counter, this is your timer. So what is this timer? So these are also do not physically exist. They come in many varieties and increments. So the most common type is an on delay type. So others include off delay and both retentive and non-retentive type. So increments may vary from 1 millisecond through 1 second. The next one is the output relay. This is also known as a coils. So these are connected to the outside world. They physically exist and send on-off signal to the solenoids, lights, etc. They can be transistors, relays or triacs depending upon the model chosen. And the next one is the data storage. So typically they are registers assigned to simply store data. So they are usually used as a temporary storage for math or data manipulation. They can also typically be used to store data when power is removed from the PLC. So upon power off, they will still have the same contents as before power was removed. Okay. So the next one is the PLC operation. So PLC works by continually scanning a program. Okay, we can think of this scan cycle consists of 3 important steps. So the steps are check input status, then execute program, then update output status, and then again it is back to the check input status. So these are the 3 main important steps. Such as step 1. Step 1 is the check input status. First, the PLC takes a look at each input to determine if it is on or off. In other words, is the sensor connected to the first input on? So how about the second input? So how about the third? It records this data into its memory to be used during the next step. Okay. Then in second step, execute program. So the next PLC execute program, one instruction at a time. Maybe program said that if the first input was on, then it should turn on the first output. Since it already knows which inputs are on off from the previous step, it will be able to decide whether the first output should be turned on based on the state of the first input. It will store the execution result for use later during the next step. The third step is the update output status. So finally PLC updates the status of the outputs. If it updates the outputs based on which inputs were on during the first step and the result of the executing your program during the second step. Based on example in step 2, it would now turn on the first output because the first input was on and your program said to turn on the first output when this condition is true. After the third step, the PLC goes back to the step 1 and repeats the steps continuously. One scan time is defined as the time it takes to execute the 3 steps listed above. Then the next one is the PLC response. The total response time of the PLC is a fact that we have to consider when purchasing a PLC. So PLC takes a certain amount of time to react to changes. In many applications, speed is not a concern. In others though, input response time plus program execution time plus output response time, this total equals to total response time. So the next one is a PLC response time concern. So see these pulse diagrams. See here input 1, 2 and 3. So this level is the off level and this level is the on level. So here scan 1 consists of this in, then program execution, then out. Then scan 2 is from this in to from this out. Then scan 3 is from this in to from this out. So input 1 is not seen until scan 2. Okay. Similarly, input 2 is not seen until scan 3. Again, input 3 never seen by PLC. This is the response time. Okay. So see here in this pulse diagram, from this in to this out, in program execution, then out. This is our one and then the next in. This is our one input plus one scan. Okay, to avoid this we say that the input should be on for at least one input delay time plus one scan time. This is your one input delay time plus one scan time. But what if it was not possible for the input to be on this long? Then the PLC does not see the input turn on. Okay, so the next definition is pulse stretch function. So this function extends the length of the input signal until the PLC looks at the inputs during the next scan. That means it stretches the duration of the pulses. Okay, see here scan 1 is from in, then program execution, then out. This is one scan. But pulse stretch means stretching the pulse. This pulse is initially this pulse is from this to this, but here the pulse is stretched like this. This is your pulse stretch. Okay, then the interrupt function. So this function interrupt the scan to process a special routine. That means as soon as the input turns on, regardless of where the scan currently is, the PLC immediately stops what it's doing and execute an interrupt routine. Okay, so an interrupt routine can be thought of as a mini program outside the main program. It is like a mini program. So after it's done executing the interrupt routine, it goes back to the point it left off and continues on with the normal scan process. So see Here our normal scan is from this in, then program execution, then out. This is our one scan, but here is the interrupt. So if interrupt is executed, then first interrupt will be executing and then it comes back to the point where it left out. Okay. Then the next is the relays. We understand how the PLC processes inputs, outputs and actual program. So now let's see how a relay actually works. So after all, the main purpose of a PLC is to replace real world relays. Okay, so we can think of a relay as an electromagnetic switch. We already discussed about the relay in our previous semesters. You already know about the relay. So apply voltage to the coil and a magnetic field is generated. This magnetic field shocks the contacts of the relay in, causing them to make a connection. So these contacts can be considered to be a switch. They allow current to flow between 2 points, thereby closing the circuit. See, this is one real example. Okay, here is a DC supply is given to this relay coil. So when this switch is closed, the current will flow in this relay coil. So here magnetic field is developed. Already I told here this magnetic field is generated. So in this coil magnetic field is generated and this magnetic field will close this contact, relay contact, and once this contact is closed, then this bell is on. Okay, turn on. So this is the example of simply turn on a bell whenever a switch is closed. Okay, so we have three real world parts: a switch, a relay and a bell. Whenever the switch closes, we apply a current to bell, causing it to sound. Okay, so replacing relay. So let us use a PLC in place of the relay. The first thing that's necessary is to create what's called a ladder diagram. Okay, we have to create one of these because unfortunately a PLC does not understand schematic diagram. It only recognizes codes. So most PLCs have software which convert ladder diagram into code. So actually PLC is a programmable logic controller. That means here we use some logic. So these logics are implemented by some codings, by some programs. So after implementing these programs, one logic is performed and then the controller works. Okay, so this is your programmable logic controller. So most PLCs have softwares which convert ladder diagram into code. So here this ladder diagram is one kind of logic. So this logic are converted into programming or coding. Okay, so by executing this coding, the PLC works. Okay, so in the next part we will discuss about this ladder diagram. So next, go to the application of PLC. So these are some advantages of PLC control system which I already discussed in the previous session. You just go through these slides. Okay, these are all the advantages of PLC system. So this is also one advantages of PLC system. Just go through all these things. Okay, we will study the ladder diagram in the later videos. Okay, so these are all the ladder system advantages of PLC control system. This is your PL system total overall block diagram which I already discussed now. This is the power supply, CPU, memory, program data. This is the input module. This is output module. Okay, so these are input sensing devices. Here also output load devices. Okay, this is the block diagram of PLC. You just go through this video and make note all of this. Okay. So the next part is the application of PLC. So because of the versatility of PLC, it is used in various places for automation. In industries, various processes needs to be controlled at every instant of time, such as valve control, pressure control, robotic action, etc. So it becomes tedious and infeasible for humans to control all such activities on their own. Thus, relays were used to perform those activities. However, a relay can be used only for a specific and limited operation, which makes their use bulky and uneconomic. On the contrary, PLC having the ability to perform number of tasks by simply modifying the program has become a prominent device for automation of such activities. So there are various places where PLC can be used. Some of those are listed below. So your applications are the robotic arm in car manufacturing, then air compressors, then airport runaway lighting control, traffic signal control, smoke alarm control, process valve control, textile equipments, vacuum pumps, etc. So apart from these applications, PLC is widely used in automation of electrical power system. At electrical substations, automatic reclosing, circuit breaker tripping, capacitor switching, etc. can be controlled with PLC. So these are all about the application of PLC. Okay, thank you.